Hello class, welcome back on our training for data analysis. So today we are continuing from where we ended. Today our main focus will be on matrices, how we can store matrices in R. Now previous lesson we learned about how we will store atomic data type in what? Vectors in R. So today we are come to learn how we store matrices in R. Storing matrices in R is very crucial because once we are able to store matrices in R, we can do the basic mathematical or arithmetic operations using what? Matrices. But before you can store matrices in R, what you have to know first is what? You have to know your matrix and the C function. Once you get your matrix and the C function, you constructing matrices in R will be very simple. So here we have what you call matrix, right? As you can see here, matrix, and then the C function, right? So once you wrap the matrix, you put it into bracket, and then the C function with this argument here is what? The element in what? The vector, right? So we have what? N rows, and then n rows and what? N car, which is equal to 4 and 3 respectively, right? So the n rows is telling us that we are having 4 rows, and the n columns is telling us that we are having what the columns, different 3 what columns. So here we have 3 different columns, and here we have 4 different what? Rows. So these rows and columns will give us what? The dimension of what? The vector. So here we are having what? 4 by 3 what? Vector, right? So we state this in R to make R to construct 4 by 3 vector for you. And here we see we are saying that the by row is equal to true, right? The by row is equal to what? True. So as you can see here, the by row is equal to true, as you can see here. So if the by row is equal to, it means that the first 3 elements, as you can see here, will be for the first row. The second element will be for the second row. The third element will be for what? The second and the third row, and the last element will be for what? The last row. But if the by row is not true, you will get then you solve similar example. So at the end of the day, once you run this one in R, you would like to check the dimension of that, right? Once you check the dimension, it will come. So here we are having 4 by 3 vector, as you can see here, the 4 and the 3, right? And then print the results of what? The X. So you can see clearly here that from here that you see the first 3 elements was what? For the first row, right? And then the second 3 elements is what? For the third row, as you can see there. And the last 3 elements will be what? For the last row, as you can see there, right? So I don't believe that is how we can represent what matrices in R. But for example, what about if our by row is false? When our by row is false, it means that R is not going to take our first element as what? Columns again, row again, right? But R will do it another way wise, right? So let's run this one. You get your dimension as well. You get your dimension, right? So at the end of the day, you see we have at the end of the day, you see we have what you call this matrix, right? So once you run, you get it. You run again, you get what? Your 4 by 3 matrix, and then run. So once you run, you see that R did not take the first element as what? Vectors. Alright, you took what? The first 4 elements as what? The columns. So once the by row is false, you are going to, once the by row is false, you are not going to take the element to be what? For the rows, but rather you will take the first element to be for what? For the column, as you can see here. So you see this one is what? For the first column. You see for the one here, this one is what? For the first column. This one is the second column, so this one is the last column. So here when you can 1, 2, 3, 4, 5, it will be for the first column. 1, 2, 3, 4, 5, 6, it will be for that, right? So this is how we can represent matrices in R using what? The by row is equal to true, and the by row is equal to what? False. And sometimes you see you store your matrix nicely in R, but sometimes you would like to add a new row to what? That vector, right? Or a new column, a new row to the matrix, or a new column to what? The matrix, right? We use the R bind, as you can see here, the R bind to add use the R bind to add what? Rows to what? A matrix, and use the C bind to what? Add column to what? A matrix, right? As you can see here. So at the end of the day, if I really want to add this vector into my matrix, I will just put this one into a C function, right? And then use the rebind. So here we rebind into bracket X. The X will be what? The matrix that we stored here, right? and then comma, right? Comma and a C function of what this element. This is what a new vector. You are going to add it to what the matrices. So once you run this one, it will come nice one. So you see it has added the 7, 8, 9. It has added to what the rows, and you want to add to what the columns too. Right? You use the C bind, the variable name, and the vector that you really want to add. So once you run this one, see it will come nicely. As you can see, it has add another columns to it, right? And then you see we can also use the rib bind and the C bind to also create matrices in R. Yes, in fact it's true. So at the end of the day, you see for the rib bind is used to add a certain rows to what a matrix. So here is the case that we have our rib bind here, and then we have the individual rows, as you can see here. So we are just going to add them one after the other. So we have this one will be for the first row, this one will be for the second row, and this one is going to give for our last one row. So at the end of the day, once you execute this and run, right, you see it has taken the first 4 to be for the first row, that to be for the last row. So this one is giving us what, if we really want to check the dimension of this matrix, you can surely check it, right? So DIM into bracket of, let's say, Z, right? So this one is giving us a 3 by 4 matrix, as you can see down there. And you can also create matrix using the C bind. So for the C bind, at the end of the day, we are creating it with what, columns, right? So this one will be for the first one, right? So the first column, second column, and the last column, right? So once you run, you're surely going to get your result as that, right? And then after doing all these kind of stuff, maybe you would like to find, let's say, transpose of what, a matrix, right? So if you really want to check transpose of a matrix, you just use what, the T function to bracket of what, the matrix, right? So I don't really, once you run this one, it means that you're going to transpose what, the matrix, right? And then we have what we call how to matrix what, indexing, right? So I don't really, maybe you have your matrix already there and you want to make some index, right? Matrix index, right? So I don't really, if you really want to make your matrix index, what you have to know is what, to get your variable name, the number of columns and the rows, and where you want to remove the matrix from, right? So I don't really, here we have our M as what, the data name, and the X here is what, for the row, and then this one is what, for the column, right? And if you see something like this, you see we have H and comma, right? So here you are just telling you that we can you can just tell you that we can just take what, only what, rows, and here you can just take only what, column. So for example, it means that if you don't want to get column 3, right, you just key into bracket Z bracket, open that. So once you run, it will come nicely, right? So print K, right? So you see I've gotten our 576, right, of which it has already been done there, right? So I don't really, and then if you have Z into bracket of that, once you run, right, so once you run, you see that I'll remove that thing for you, right? And then we have this one too. We have someone at what, let's say if we have someone here, so here we have already stored the matrices, right? So we want to find the value that is at row 3 column 2, right? So once you run, I will give you the output, right, nicely. And then at the end of the day, you really like to, let's say, call matrices, right, within a specific what, interval, right? So here you want it to be from 1:2 and then 2:3, right? So once you run it like this, right, we are just taking the 1:2 and then 2:3 and then print nicely, right? And sometimes you want to add perform operations, right, logical operations using what, R. So I don't do the matrix operation, you are just going to add and subtract about 2 matrices. So these are the 2 matrices that you have. Once you print addition, it's surely going to add. Once you print subtraction, it's surely going to add. Once you print and multiplication, it's surely going to add, right? So getting diagonal matrix right? So maybe you have done return analysis and you want to get diagonalization of what your matrix. Just come here and then run, right? For the sum you get it, the maximum you get it, the minimum you get it. So this is the end for what matrices. And so kindly take your time, go through and write the quiz and run it yourself, so that another day you become well equipped with. Thank you for joining. This is Statistics and Mathematics Teacher channel. Kindly share, kindly share and subscribe so that other two will have benefit on this video. Thank you.